We'll try to fix it today, okay? All right, we've got 14 randomly selected countries. They give you the residual plot. They tell you what the explanatory variable is and the response variable. So we have to write the equation of the least squares regression line based on the data. So guys, from up in your computer printout, who remembers what numbers we actually need from that to write our equation? This is no different from what you did in Unit 8.
Which one's the coefficient and the...
Yeah.
Regression. Or R-squared.
These coefficients, and then we are going to use the R-square later. Yep. But the coefficients there are what you use to write your equation. And hopefully that makes sense. Like coefficients should be used in your equations. Yeah. You didn't get one of those? I'm sorry. That's great. So we're going to have y hat equals, now which of those, the 65 or the 0.02, is the y-intercept? The 65. So we're going to have 65.44.
How do you know that? Because it's the constant?
Because it's the constant, yes. It's the one without a variable.
And the constant is always the y-intercept?
Yep. And then the other one, it's saying it's the coefficient on cigarettes, and the cigarettes is your x variable. So we know that's your slope. So it's going to be plus 0.0, and you can write however many decimals of it you want. 0.02268 x. And they stated it up above, but it says to define the variables used. So we know y hat is the predicted deaths per year. I think it was from CHD, coronary heart disease. And then your X is cigarettes consumed, which just sounds really gross. Sounds like you're eating cigarettes. Per person per year. Okay, so far same as Unit 8, right? All right, then it says interpret the slope. So we know which one is the slope, right? The 0.02268, that's your slope. Anybody want to take a stab at what that actually means, how we interpret that? Or are we in the sit back and just consume information state right now? Go ahead, Patrick.
I had it for a second.
Loaded.
So for every person who consumes a cigarette,
Okay.
the amount of people with CHD will go up 0.02.
Okay, yeah. So for every, I'd just say like one additional cigarette or one cigarette consumed. And then we'd want to include we expect deaths per year. To increase by that 0.2268. Oh, 0.02268, sorry. And you might have included something about deaths from CHD, or, you know, you can always include more information in your description there. So far, so good. Yeah.
So is it different in this that we say it's N?
Oh, I'm just saying that's what the slope is. I'm just noting what it is. You could call it B too. I just went back to algebra. We'll do this so then I don't confuse you. I'll just write slope equals. All right, so then part 3, we're trying to determine the relationship between these two variables. Is the slope you provided in part A a statistic or a parameter, and explain? What do you guys think? I haven't asked you the difference between statistic and parameter for a while. Do you think the slope, I feel like I'm missing a page here. I clicked too fast. There we go. What do we think? Yeah, exactly. It's the slope from our sample, right? So yes, you are completely right. This is a statistic. The slope is an estimate based on our sample, or on this sample.
What would an example of a parameter be?
Parameter is always connected to your population. So if you actually had the true slope of the population, that'd be a parameter. But if we knew that, we wouldn't need to do this regression.
So if it's an estimate, then it's a statistic, but if it's known for sure, then it's a parameter.
Well, and if it's an estimate, like your estimate is coming from a sample, right? So anything from the sample is a statistic. Okay. All right, so part 4 here, based on the information given, discuss whether conditions have been met to use T procedures to make inferences about the slope of a regression line. Okay, so now we're clearly into the Unit 9 stuff. We didn't talk about T procedures in Unit 8 at all. So in the notes, I went over like liner, L-I-N-E-R, those are your conditions that you have to check. And you can check pretty much all of them from the residual plot, most of them at least. So I would say we'll list them out. The L stands for linear. The I is for independent. N is for normal. Equal variance, and then random. That one I believe was stated, right? That's the only one that we would have to just look back at the initial part. Yeah, it said randomly selected countries, so that one's stated, but the first 4, all you need to do for me is list those and then say, hey, these are all good because the residual plot shows a random scatter for cloud. I don't know what's happening back there. Oh, yes, of course. Sorry, I couldn't spell backwards well. Yeah, go ahead.
So these are all good because it's a random sequence.
Like those conditions have all been met. You know, with our others, how we had very specific, like you'd have 2 or 3 conditions and you'd have to show like n times p and n times 1 minus p. This is the version of that when you're doing regression. You check all of them off by looking at the residual plot.
Well, so if the residual plot was like not a cloud and it was a line, would they
Yeah,
still all be met or no?
No. So let's say our residual plot was like that. Problems, okay? Like that shows a very clear pattern. So you'd be like, hey, I didn't meet the conditions.
Okay, so you don't want a pattern.
Don't want a pattern. You want just a cloud of dots. And sometimes it's like this only has 14 in the sample. So, you know, a cloud of 14 is different than a cloud of 100. You know, it's not like that's not like this perfectly spaced out cloud, but it is good enough for what we're doing. Okay? Are we all right with that?
Will it always be like for the square plot?
Unless it's something where it's like, here's the initial one, and it had a pattern, and they say, then we did the log of both sides, and here's what we got. And then it's so if it's one where you need to like straighten your data or use a different, but your actual doing it will always work out.
So if it's linear, then would we just say conditions not met? Or would you have to like go by each?
Oh, so no. Yeah, you could just say conditions were not met because the residual plot showed a pattern.
Okay.
You wouldn't have to be like, this condition wasn't met, this condition, just say conditions are not met.
Okay.
Like, that's okay. Yeah. I see what you're saying. Doesn't have to be that specific. Okay. Assuming all conditions have been met, which they have, we're going to construct a 90% confidence interval for the slope. I think that's hard because it's this weird combining of a confidence interval and slope of a line. Like, that's hard for your brain to wrap itself around. So, let's just walk through it. Excuse me. Thank you. I'm sorry. I wish the windows opened
Yeah.
more. They're just like these little
Yeah.
cracks of windows. All right, so when you're doing your confidence interval, it's b sub 1 plus or minus t crit times the standard error, so times SE.
Now do we go back to this?
Yes, we use that computer printout for a bunch of this. So first, b sub 1, that's talking about your slope. So since you're doing, you know, a confidence interval for slope, it makes sense that slope is actually in the process of what you're doing. So that is going to be that 0.02268. Plus or minus. Okay. The critical T. Do you guys remember how to find a critical T? Use inverse T. Your calculator. And your degrees of freedom is n minus 2. I'll pull up my calculator and show you here. When you're doing slope, it's 2. I know. Because that's how math works? Sure. Sorry, guys. Can't, like, process two things at once here. Let me get this open. All your extra notes.
Yeah. But they have some.
That's okay. That's good, because then you remember, like, okay, this is what I was actually doing. All right, so if we go to the distribution menu, so second, vars, You see inverse t down there. So number 4. Okay. We're doing a 90% confidence interval. So remember, it's been a while since we've done this too. I'm talking about the middle 90%. How much does that leave in each tail? 5%. So you can either use 0.05 as a barrier or 0.95 as a barrier. One will give you a positive, one will give you a negative, and it doesn't matter which one you use. So I will use 0.95. So remember, 90% confidence does not mean put a 90% in here, okay? It's that middle 90%. Degrees of freedom would be 12, because we had 14 minus 2. And let's see, are you getting either positive or negative 1.782? The what? The 12? The part you don't like, the degrees of freedom and minus 2. Oh, in the problem it said the sample was 14. In the paragraph up above. Magic, again. All right, so this, coming back to you, this whole inverse t stuff, okay. So, my t crit, I'll just use 1.782. All right, and then back to your computer printout for the standard error here. Do you think we want the standard error for the constant or the standard error coefficient there for the cigarettes?
Cigarettes.
Yeah, isn't that much more related to the slope and like what we're talking about? Yeah, so it's this 0.01926 that we're going to need. So whatever note you need to make for yourself, like, hey, this is the one I use for standard error.
Oh, is that what the SCs?
Yes.
So we will never use the constant standard error coefficient.
Nope, you don't need it. There's a lot in that computer printout that you don't need. It's just there to mess with you. Okay, so now you actually just have to key this into your calculator.
What did the 1.782?
That's the critical T. That's where we did inverse T.
Oh, okay.
Yep. No, that's what I want you to do, guys. Ask those questions if you're like, oh, I don't know where that number came from. Like, please ask so you aren't just missing part of this because you're just stuck on one number, okay? All right, guys, what'd you get as your interval here?
Negative 0.012 or 1,
That's fine, yeah.
and then 0.057.
Yep. Okay. And again, that's just from keying in those values, adding and subtracting them. And this is the way you have to do it when you're given the computer printout. If you're given the information in a different way, you can actually use the T interval on your calculator, but we didn't have the information in that way. So got to know our formula and do it this way. Just like we did before, you have to write your conclusion. So we are 90% confident. that the true slope of the regression line for predicting annual deaths, and you can say by CHD if you want, from annual cigarette consumption per person. So again, it's back to what you were doing before with confidence intervals, just now you're talking about slope.
You need to like write that values.
Oh yeah. Is. I'll just say is between negative 0.012 and 0.057. All right. Stuff you've seen before. Give me a second to make sure everybody's okay there.
This might be a stupid question.
No, you're fine.
But what is the like units here? Like it's between negative 0.012 what?
Deaths. Like for every additional cigarette consumed, deaths either go down by negative 0.12 or go up by 0.057.
Okay, it's just like somewhere in that range.
Yep. It's a weird result. Okay, so then question 6 is asking you about if you performed a hypothesis test with beta equals 0 versus beta not equal to 0 at the alpha equals 0.10 level. What would you conclude? And it says to justify your answer using your result from question 5. So it is not telling you to do a full hypothesis test. What do you think is important about the interval we got in question 5? Yeah, Patrick.
We can't rule out that cigarettes don't affect. That's
Yeah, what number is included in this interval that is important? 0. Yeah, so you can't really make a great conclusion here because the slope could be negative, meaning deaths go down by cigarette consumption, or it's positive, meaning deaths go up by cigarette consumption. So that's basically what you have to talk about. So we're just going to say since 0 is included in our 90% confidence interval. Thanks. Hey, you're leaving us. We cannot reject the null. Yeah, just set it all there. That's fine. Thank you. At the alpha equals 0.10 level. There is not enough evidence to suggest. Yeah, you. And I'll post the video if you want to watch this going over it. Okay. Yep. that there is a linear relationship between cigarette consumption and annual deaths from CHD.
Will there be questions from the test with hypothesis testing?
Yeah, we're gonna actually go through a hypothesis test today too. Turn the page, we'll get a season. Okay. Maybe we don't do a full hypothesis test. We did one in your notes. Did you take the notes? Like, did you watch the videos and take them?
Yeah.
Okay. Do you remember doing the hypothesis test?
Do I remember them?
No. Okay. Oh, look at those again. Yeah, Haley. Yeah, go ahead. All right, guys. Questions on this first part? Okay. Let's turn the page here. So this is flipping it over for you guys. We got all sorts of information in here. Lupe's shopping for a used car. She's got all sorts of data. And here's the computer output for different regression models. The first one is just price versus age. Then we have log of price versus age and log of price versus log of age. All right, and then we're using this info to answer the questions on the next page. So you've got all these different computer printouts, graphs, and residual plots. First, one thing I want to note here, if you have the log, this one here that's log of price versus age, that's called the exponential model. And if you're logging both parts, that's called the power model. First one's just the regular old linear regression, nothing weird happening there. All right. So you're given information. It says explain how that information provided suggests that a linear model may not be appropriate for describing the relationship between car, age, and price. So if I look at just this linear information there, what do you see that's problematic? Is your scatter plot linear? Or is it maybe like a little bit curved? You guys see the curve in there? Like, it doesn't look like a real straight line to me. And then if you look at the residual plot next to it, what do you see? Is it a nice happy cloud? No. Yeah, it almost looks like a little parabola shaped pattern there, right? Okay, so those are indications that, like, hey, this is not the right model to use. So that's what we'll answer in the first one. You could say something about the scatter plot shows a curved relationship.
So on that, are we looking for like if they look the same?
Not necessarily. You're just looking for patterns. So the scatter plot doesn't necessarily have to match like a residual plot pattern. It's just like any pattern in the residuals is problematic. And anything that's not straight in your regression tells you it's not linear. But they don't necessarily match. Okay, so shows a curved relationship between price and age. And then you could also mention the residual plot. Is not a cloud. Or you could say shows a pattern. Okay, so question 2, then they want you to pick which of the other models is a better fit. And they ask you about the exponential or power model, so that's why we renamed those. What do you think? Exponential or power, which looks more linear? Yeah, exponential. This is the one we're going to want to use. You've got a decent cloud-shaped residual plot and a pretty straight regression or scatter plot there. The power one looks curved in the other way. It's like you overcorrected too far in that one. So we would pick exponential. You could say the scatter plot is linear. And the residual plot shows a cloud or a random scatter. And you could say something about the power model does not show a linear graph. Yeah, go ahead. Yeah, so if they're both logged, like where it's log price and log age, that's called power. Where it's got just the log on price and age you leave alone, that's exponential. Okay. All right, so now we need the equation of the model that we chose in question 2. So we picked the exponential, so now we need to use our computer printout to write the equation. So what 2 numbers am I using here? Yeah, these 2, right? The coefficient, the 1.43723 and negative 0.09. Okay, now the weird thing with writing the equation, we can't just say price equals this or predicted price equals it. We have to say log of price, because that's the transformation that was used. So our equation, I'll put the hat on it and say log of price. So predicted log of price is the 1.43723. And you don't have to use that many decimal places, okay? Minus the 0.09065 times age. Are we okay with writing that equation? All right. For 4, then, we have to be able to solve a log equation. So some of you might be having flashbacks, but we can do it. All right, it says use the model to predict the price of a 5-year-old Ford Taurus. So I've got log of price equals, I'm just going to say 1.44 because that's way too many decimals, minus 0.09 times 5.
Since you wrote log price and then age instead of X and Y, is that why you didn't use it?
Yep, exactly. Okay, so to solve this log of price, I can get whatever this decimal is over here, right? I don't know. I changed my numbers. Now I don't know what it is. Let's see. 5 years. 5-year-old Taurus. Like, that's just what they're supposed to plug in. I got like 0.99. If you left all the decimals in there, you get like 0.98398, something like that. Do you think that's the price? The predicted price is 99 cents. No. Yeah, how do I solve this log equation? Exactly. This is a base 10 log, a common log, so the predicted price is actually 10 to whatever value you got over there. So if you go back to all the decimals, it's like 9.64. What is it if you do just 9.77? Okay.
Yeah.
Now, again, it's also not $9.77. What is it? What did we give price in here? Yeah, so this means the predicted price is $9,770. Or if you used all the decimals, it was like 9,640, depending on your rounding. And they're both fine, like as long as you're just showing what you're doing along the way. No issues there. Okay, questions? Yeah. Like, why does it change from 9.77? Because in the information you're given over here, they tell you the price is in thousands of dollars. That's why. So it's not really like $9, it's the $9,000. Okay. Other questions? Yeah.
Why did we do like? I don't even know how to phrase this question. But, like for this one, we did so many steps and so much work. Why did we not have to do all that tests?
So it was asking different things. So the first part, like, are you talking back to like these, like all of that?
Yeah, like we didn't do conditions for this one or like stuff like that. We just like skipped some steps.
No, the second one here with all the computer printouts, it didn't ask us for a confidence interval or a hypothesis test. So you don't have to check conditions.
Oh.
This was just like, here's your model, pick the best model, make a prediction with that model. It could have continued and said, using this model, what is a 95% confidence interval of the slope? And then you'd have to go through conditions and all of that stuff. So. All right, we okay? You guys don't look okay. I think we're okay. I know it's hot in here. All right, so hopefully that helps jog your memory a little bit on what Unit 9 is. But things you have to work on. You've got the AP Classroom quiz. I think it's 14 questions. Due Thursday, right at the beginning of class, I believe is what I set it for. You've got Khan Academy. It's just one. I think it's the test this time, but just one of them. Also due Thursday. And then I've got extra review with multiple choice questions if you want a little more practice with that in the P. So I'll pass that out.
Is this test like shorter? Or
It is shorter, yeah, and it only counts for half a test.
okay.
Okay. So keys on the back. This is extra multiple choice practice. So use your time. And guys, we'll probably have time on Thursday if you want the first part of class, if you have questions or anything that comes up. Talk about those then too, okay? You can do it, guys. I do believe in you. All right. Just add it to the pile there, Ethan.